You might not care if somebody knows that you bought a vacuum cleaner on Saturday, but you'll definitely care if they have your account information.
That was really creepy, Patricia. I literally bought a vacuum
Did
cleaner
you
on
really?
Saturday. Did you? No, no, I'm just joking.
Okay.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy, featuring discussions with entrepreneurs at the forefront of deploying machine intelligence and brainstorming sessions about where the technology may go at the limit.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy. I'm Ajay Agrawal, co-founder of Intrepid Growth Partners, and my three collaborators are Rich Sutton of the University of Alberta, who pioneered reinforcement learning, Sendhil Mullinthanan of MIT, who uses machine learning to better understand human decision-making, and Niamh Gavin, an applied AI scientist working on optimizing open and closed foundation models. Rich, Sendhil, and Niamh are all senior advisors at Intrepid Growth Partners. The domain we're exploring in this episode is privacy, personally identifying information and confidential company information. We're here with Patricia Thane, the co-founder and CEO of Private AI, that detects and removes PII, that's personally identified information, in a client's data and keeps it safe. The company also gives organizations a finer grained understanding and control over what data they collect. Private AI is headquartered in Toronto. And with that, let's start the show. And so Patricia is an alum of University of Toronto. She did her PhD here in computer science and is founder and CEO of Private AI. So Patricia, over to you.
Yeah, sounds good. Great to meet/see everybody. So yeah, we do many things. Redaction, identification of personal information is a core part of it. We can focus on the use case of privacy preserving in large language model ecosystems. So for redacting prompts, redacting training data, redacting contextual data for RAG embeddings, if you want to focus on that, because it seems to be what's the hottest topic at the moment. And we could add confidential company information in there as well, because two of the main concerns at the moment that we're hearing is folks don't know what's in their data for large language models, and folks don't know how to do proper access control within the data that they're trying to use for large language models as well.
Excellent. And Patricia, can you just describe a little bit of how you do redaction or how you protect information from going either into or out of these language models in terms of effectively predicting what is private information and then redacting it?
Yeah, well, essentially we use named entity recognition models, and we also have the ability to do things like co-reference resolution if you're mentioning two organizations in a different way, like Pepsi and PepsiCo, or if it says Ajay and Ajay Agrawal, being able to detect that those are the same entity. And the way that we go about it is by stripping out the personal information before you send a prompt to a third-party large language model, and then reintegrating the information into the response. And then if it's for training data or data for fine tuning, we can do that redaction process, but we can also replace with synthetic personal information as well. It actually has the added benefit of helping with bias, because several quasi-identifiers like political affiliation, like religion and location can lead to bias in the responses of large language models as well.
All right. And so Sendhil will kick off. He's thought a little bit about bias and also just for all the listeners to kind of get the magnitude of the problem is that many companies are struggling to use even the most basic tools because of fear of non-compliance with private information. So in other words, the fear of non-compliance is one of the greatest barriers to innovating and utilizing these very powerful technologies. So Sendhil, over to you to kick off.
Great. I have three questions, and yeah, building on what Ajay said, this is just such a fantastic use case, Patricia. It's one of those sort of things that unless you're in it, you wouldn't realize how important, how big the market is, how valuable it is. So just I just love the use case, and it shows a lot of knowledge and wisdom in choosing it. So my questions are sort of going up in levels of, I guess, complexity. To just start with the simplest one, you sort of talked about both PII and about sort of confidential company information. So personal information, identifiable information, I can see how named entity recognition could solve that. I think I'm trying to see what would scalability look like for confidential company information. So like if I'm Coca-Cola and I've actually written down my secret formula somewhere, that's clearly CCI, but that's not really named, entity recognition. I guess if we took everything that names carbon, oxygen anywhere, but suddenly we'd be redacting too much. So how do you think about the labels for a supervised learning pipeline for any particular company for things like CCI?
Yeah, that's a great question. And that it does vary company by company, right? There are some things that are just across the board confidential information. Sometimes logos for customer, if you're sending customer data through or decks. Also, financial trends, metrics, organization names. So there are some things that you can use named entity recognition for, and fairly so straightforwardly. The way that we're enabling it for other confidential information is by having the user input what it is that is confidential information for them in that particular period in time, because it can also change, month over month, quarter over quarter. And the tricky part is also if, there are spelling mistakes or optical character recognition errors or automatic speech recognition errors, how do you capture those? So those are some of the questions that we're working through with our customers at the moment.
And when you enter it, is it at what level am I? Because I can see how it would work for supervised learning. You just give me a bunch of examples with labeled instances. I'm just going to learn off of that. But if I'm entering it, is it sort of a high-level semantic description? Is it in some more formal language structure that you have in mind? How are you thinking about that entry process by which I describe it?
Yeah, for now it's basically a block list. But down the line, ideally, as we learn more from a company by company perspective, our plan is to come up with something that is a little bit more.
So it's sort of more like it's closer to search and block, for example.
Yes.
Just I'm trying to got it.
Exactly,
Yeah.
exactly.
It would just strike me as a point of thing. I would have thought that a fantastic thing that would give you a lot of scalability is sort of solving that little ML piece, which is how can a company efficiently describe, because I think a person could describe it. Like if I was the head of a company, I could probably describe it in English. I'm not sure that we have the tools to convert that English description into a practical thing, but maybe we couldn't. I mean, it sounds like you're saying a company trying to describe it itself would already be a bit of a hard problem.
No, it's very much still a hard problem within the company itself.
Interesting.
One example might be the color of a product for a particular period in time before that product is launched.
Mm-hmm. Oh, that's fantastic.
You're going to block all colors, right?
That's fantastic.
Yeah.
So I guess a way of saying it is that seems like an amazingly interesting problem and a source of competitive advantage, and a way for you to build a moat if you can track that problem. So I'll move to my next layer of sort of complexity. The next layer is there's one of my favorite articles in this field is actually a New York Times article. I don't know if you ever read this. It's got a beautiful title. A face is exposed for AOL searcher number 4417749. Have any of you read this? This is a milestone in privacy, Patricia. This really came to define. I mean, it was almost a bombshell when it happened. So AOL released this data set that like the computing community that worked in this area just loved. It was search logs. It was de-identified search logs that just like, we took out people's whatever. We didn't give their address. It just says like numbers. 4417749 was a searcher. This was a thing that showed how like, even though the community had been using this for a while, suddenly there was this problem that blew up, which is somebody took that searcher, took the individual searches they had, landscapers in Lilburn, Georgia, homes sold in Shadow Lake. So it's just a few searches. And they were enough to narrow down that this searcher was Thelma Arnold, a 62-year-old widow. And this is like a bombshell.
Yeah.
Because literally they found a person that was a searcher, and now we knew everything Thelma did.
Yeah. And it turns out that people like searching for themselves a lot too.
A great point. I mean, here they didn't have the name Thelma Arnold, but actually you're right. She did search for several people with the last name Arnold, so that did help them. Thelma wasn't as egotistical as some of us are, like, oh, what's going on with me? But I think the reason I'm emphasizing this is that to me, this is what started a lot of concerns about privacy. But it also illustrates some of the complexity of what PII really is. And so I guess part of what I guess I'd push you on is how do you think about the fact that even if we remove Thelma's name from the AOL search logs, we can re-identify Thelma.
Yeah, great
And
question.
and I would have thought like for some applications it doesn't matter. This is just going into some big statistical machine. That's fine. For other applications, this might matter a lot. Like how do you think about that side of things? It seems so important to what you do.
Okay, so this is quite the deep dive you're asking me to go into.
Yeah.
All right, so let me take you back to some work that Professor Sweeney did out of Harvard, where she was basically showing how you can re-identify the governor of Massachusetts, and you could identify him from the zip code, and I think it was a date of birth, if I'm not mistaken. Would have to double check that. But basically, two pieces of identifying information could pinpoint this person with a large amount of certainty. And this was a pivotal moment in healthcare data de-identification because people forgot to, that maybe they should calculate the statistical risk of re-identification when it came to making data sets public. The community has been learning more and more over the years what it is that you should be considering re-identifiable, how to calculate the risk associated with it. Professor Khaled El-Imam out of Ottawa does incredible work in this area. And it really depends on a few things. Okay, naturally, all direct identifiers like full names, account numbers, those have to be removed when it comes to de-identification. When it comes to quasi-identifiers, you basically have to understand either what the risk of re-identification is within the data set that you're looking at, or what the risk of re-identification is as a statistical portion of the population. So as you add more quasi-identifiers, the risk of re-identification increases exponentially. And when it comes to things like unstructured data, it actually turns out that a lot of the times you don't need the personal information in order to use the data for a lot of the tasks. And there was a misnomer of, you may have heard Cynthia Dwork's anonymized data isn't, right? It's not useful. But a lot of misconceptions come from what we knew about structured data, which was mainly made up of fully personal information for the majority of the time. When it comes to unstructured data, if you remove personal information, you can still get things like conversation flow. How well did the conversation go? Does this customer service agent need training? What was the sentiment associated to a particular product? But in addition to the utility being something to keep in mind when you're de-identifying data and what it is that you need to keep within there, you also need to consider what the risk is that somebody may try to re-identify the data as well. So even in cryptography, you're constantly battling bad actors. Your key can get exposed. There could be quantum machines that break your crypto systems, and you're constantly having to improve your systems and build up more and more barriers. Think of de-identification or even data minimization as one extra barrier that you can add to make it very difficult for bad actors to gain anything from the data.
I feel like I get a lot of the pieces now, and so maybe just to close this part of the conversation off, how do you think about assembling all the pieces together for any particular use case? Or is it sort of calculate the risks and present the risks of different menus back to the company? I mean, how do you think about that collection of stuff? Is there, like, we've done work in healthcare, and I think the nice thing about healthcare is there's comfort in numbers, where I think there is sort of well established by now norms of what does it mean to remove PHI. And so like there's at least safety. I'm just doing what everyone else is doing, don't ask me. But early on there wasn't. So when x-rays were starting to come there, people didn't know how to remove PHI from x-rays. So putting aside the comfort in numbers, since you're creating the market, how do you think about pulling everything you just said together? How does that get put together?
It is incredibly use case specific. And I do want to say that the goal isn't always to de-identify, right? Sometimes the goal is to redact key information like credit card numbers because you don't want your identity to be stolen. You might not care if somebody knows that you bought a vacuum cleaner on Saturday, but you'll definitely care if they have your account information. So it's about...
That was really creepy, Patricia. I literally bought a vacuum cleaner on Saturday. Did you? No, I'm just kidding.
Okay, well, I use this example a lot, so it's bound to happen one day. Law of large numbers. You think about it in terms of what you need to do with the data, what kind of risk is associated with the data, what kind of permissions do you have to use the data. So this is actually a side note, very interesting problem that organizations are having right now. They have no idea what they agreed to use the original data for. And so they don't know if they could use it for training large language models, for example, or not. But anyway, what you can do with the data, who has access to the data, what additional security measures you have in place, and what the likelihood is that somebody tries to get access to the data maliciously. So there are various measures to keep in mind.
Thank you.
To add to that example of identification via your existing digital footprint, there was this brilliant kind of demo that just went out recently of whereby using open source tools that are available, a couple of kids went round to like the local train station, just use their camera to scan the room, find the face, and would go up to those individuals and be like, oh, hey, you work at Blackstone, right? Yeah, we met at that conference last week. How's it going? We need to follow up on the pitch that you're doing. And because they had so much contextual information, you know, the person on the other side was a bit taken aback, but then fully engaged just because it was all too accurate. So that's the whole near-term future that we have to look forward to. But getting back to the topic in hand, similarly echo Sendel's comments around it just being a super pragmatic tool that's addressing a real current need, which is quite refreshing in the field. But a similar line of question, but on the synthetic data side, around that parameterization of keywords into identifiers such that you actually generate a like-for-like that's still contextually relevant and preserve that statistical utility. Mm-hmm. Technically, how do you go about solving that problem?
So we don't handle that too much. And there are certain things. So if you are using a synthetic data provider, you should understand how they're calculating risk and how they're calculating risk of the data, the original data being exposed in the synthetic data. If, for example, you're using differential privacy within your pipeline, you're going to have to calculate epsilon values, delta values properly. And there's maybe a handful, maybe a couple of handfuls of experts in the world who know how to do this properly when it comes to really complex systems. So I wouldn't just take the word of synthetic data being privacy preserving at face value without understanding what the underlying risk assessment was.
Sure. I think the question was also to the contrary of that, as to that the data they generate isn't too absolutely unrelated, that it's not even applicable for kind of the training the model because they've abstracted away all of the contextual parameters such that it's now just an unrelated entity, right? It's a fine balance between the two.
It's a fine balance. And also with regards to thinking about the use case, right? You basically have to generate new synthetic data depending on the use case and recalculate those risk parameters accordingly. Again, in this space, Professor Khaled Al-Imam does really interesting work. And it has been used in healthcare and in pharmaceutical research for very, very effectively with HIPAA compliance in particular in mind.
Rich, over to you.
I have just a couple things. One is I do appreciate this whole thing about the arms race between the de-identifiers and the identifiers. In the long run, it's probably impossible to preserve privacy totally against a determined, hacker. They really just want to find out one particular thing because, your large language models and your redactors will always are not 100% reliable. And if someone was really wanted to do it, devote all the resources, they can figure things out. And I don't think that's what this is about. I don't think that's what creating more private world is about. It's about changing the cost structures. And that I believe was essentially your answer, pay attention to the use case, things you care about, things you don't care about. And if you raise the barriers, then it becomes effectively a phase change in the amount of privacy you have. I think I like that. The second thing I just wanted to bring up, this company, this organization that I've heard of called Venice.ai. And you probably know about them, but let me explain for everybody. Venice.ai essentially is an interface to open source language models and that preserves some privacy. And normally you send your query to ChatGPT and OpenAI knows about your query and they save it forever and they use it in presumably useful ways, but presumably not nefarious ways, but they definitely save it and they know it. Whereas the idea with Venice is that the query is sent to the open source AI systems run in such a way that it's never saved, can't be saved. And so they claim you have a much greater level of privacy if you use unredacted prompts to Venice, because they'll never be saved and stored. Yeah.
Those are two very interesting points. For the first one, you're right that it's very likely, if we're trying to anonymize all data, that if a very motivated actor would likely be able to re-identify something within there. Oftentimes, anonymization isn't necessarily the goal, because in some cases, like the credit card number example, all you want is to remove it. And if you remove it, it's not there. There's no way you're going to figure it out. And I love to see these other examples of privacy preserving large language models in action. If you are deleting the query right after, that's an excellent way to preserve the privacy. Still, I would recommend de-identifying data between yourself and a third party regardless, because there can always be accidents, always be malicious actors, regardless of whether they want them in their system or not. But that is a prime example of how data minimization can help with privacy.
Our conversation made me realize a lot of that might be true for PII. And I might reframe, at least in my own head, what I've done, and I don't know if this is helpful for you. I might reframe the core contribution of what you're doing, which is there's a lot of interest in privacy, a lot of interest in confidentiality, but it's almost like a continent that we have not really explored or mapped. And it seems to me part of what your activity is doing is starting to build a map of that territory, if that makes sense. Like, what are the kinds of CI? What are the kinds of PII? How should I go about thinking about it? How should regulators go thinking about it? And it strikes me that given the huge effects regulations will have on this space, and given it would seem to me that even at the limit, this is less of a computation. I feel like there are two kinds of computational problems. Those that are relatively well posed, and what they need is innovativeness in the computational side to solve them. And those where the core problem is that they are ill posed to begin with. And this one strikes me as one that is very ill posed to begin with. And it seems to me the limiting thing that you would provide us is to help us start posing meaningful CII and PII problems. And I think as a society, we know there's a need, but don't quite know how to pose it. So I know that's not a question. It's more of a comment. It just strikes me as I might have thought of it that way. And then therefore, I might have thought of myself in the role of market maker. And that strikes me as a different startup profile than a market, like meeting people where they are. In some sense, what's nice about your business is you are meeting people where they are, so you're getting revenue. But I would have had an ambition that I'm going to actually make this market. I would have fundraised a lot more. I would have taken some of my money and actually just hired a lobbying person or a person who knows Washington. Like literally, not to lobby, not for that purpose, but for taking hold of the marketplace for ideas. This company, Pymetrics, Frida Poli, who I work with, I thought they did an amazing job on this because they didn't just sell a product on hiring to companies. They realized part of what we need to do is we're making a market. And we need to actually invest some of our resources on the policy side. And so it would strike me that you have that type of similar broad stroke ability to move and make the market.
Sendhil, to clarify for the listeners, when you talk about making a market as opposed to not, let me paraphrase and see if this is what you mean. Not making a market means that you're a software vendor that takes the rules or regulations as given, and then you build a tool to help your customers comply with the rules as given. As a market maker, I think the distinction you're making is that you are going to do two things. One is build a product to help your customers comply with the regulations, but two, you're also going to try and influence the regulations. Is that what you mean?
100%. I would add one thing. It's not just rules and regulations, but even customer demand. So Etsy made me want things that I didn't know I wanted. So I would say it's rules, regulations, and customer preferences.
Okay, excellent. Thank you. Niamh.
And as always, that always tees up my kind of comment perfectly, in that I think that exact model is a more defensible one long term, because otherwise there is an element, as I was listening to you, of that kind of reductive slope whereby we almost simplify the problem to the simplest element. I just care about the credit card. And then over time, we're like, okay, and then we get the AI to automate that to free up humans for more valuable tasks. but then it can become a recursive loop whereby if the more we hand over the encryption and the security to the AI, the easier it is to also reverse engineer. So I think this always adding that element of critical thinking, shall we say, atop of it is a great blend.
Wonderful, Niamh. Thank you. And Rich, on your side.
Well, my last thought is about if we take it to the limit, is it involves sort of an adversarial component. So you're trying to de-identify things. You could also have somebody that an adversary that tries to do the identification, and you can invest various amounts of resources into that de-identification process. And if someone really wants privacy, then you spend the money and give them a greater assurance because you've spent more resources trying to remove their privacy and found it to be hopefully impossible. Or if they do find it possible, then you can fix your processes so that doesn't happen.
And Rich, how would you imagine, when you're taking this to the limit, how would you imagine from an unsupervised approach to this problem of setting a reward function? Like, what would the reward function look like here?
Yeah, well, it's surprising that I didn't, as I always take everything to reinforcement learning, as you know. But I wasn't thinking that far. But now that you've asked me, how does this adversary work? Well, his goal would be to find some. Well, I guess his goal would have to be his reward signal. His goal would have to be something that he self-specifies. His confidence that he has verified some personal information about the person or the company, and that would have to motivate his searches. Yeah, I haven't really thought through how the adversary would work. I mean, the adversary could be a person.
I was about to say, it's almost like traditional red teaming, right? But then you almost take a GAN approach to that loop. It's almost your quality control pre-release. Okay, let me have an automated testing pen whereby I give a nefarious actor a reward function to de-identify what I've tried to encrypt and see how that goes. It's super interesting.
Patricia, the last 30 seconds are for you.
Yeah, thank you so much for that. The intellectual question is a really great point. If you're thinking about the various different types of data and what the utility is that you're going to associate with them. Sendhil, you mentioned X-rays. So for DICOM images, we can remove text and metadata that might be identifiable. But if somebody, for example, has a piece of jewelry, that can re-identify them, right? And as far as I know from the research that I've read, there's nothing out there that can help you properly modify the image and also keep the utility of the image. So that utility question is so important when you're thinking through this problem from a dataset by dataset perspective, from a data type by data type perspective, and even from a linguistic perspective. What you can do with Romance language characters or alphabets is very different from what you might be able to do with logographic languages. It's so many different things that our team has to think about when they're handling different kinds of information. And so thank you so much for this great conversation. I really enjoyed it.
Great. Thank you, Patricia. And Sendhil, Niamh, and Rich, thank you. And that's our show for today. Thanks to Rich, Sendhil, and Niamh, and a special thanks to Patricia of Private AI. We've also posted links to our hosts and guests' social media feeds and web pages in the show notes. Follow us on the Intrepid Substack at insights.intrepidgp.com, rate the podcast, and subscribe on your favorite platform for content including YouTube, Spotify, Apple Podcasts, and more. Thanks everyone for listening.
The views, opinions, and information expressed in this podcast are those of the hosts and guests and do not necessarily reflect the official policy or position of Intrepid Growth Partners. This content is for informational purposes only and should not be considered as financial, investment, or legal advice.